Gary mentioned, I'm Vibhu Bhutani, I'm Chief Strategy Officer with Softweb Solutions. Just to give you a little bit of the background, so today we are presenting combining the amazing forces of AI with IoT. Obviously, we have talked about IoT a lot. IoT has been in, for some around more than 3-4 years as IoT, but obviously it was connected products and, different digital products before that. But since IoT has been evolving, there's a lot of places, lots of data getting collected, and AI is a place where we are using that data, we are using artificial intelligence, machine learning programs, and to make sure that the data that is getting collected is being utilized in a better fashion. So to start with, this is a very high-level agenda that we are going to cover today. Obviously, we will talk about what the company does, what we do, basically. Then we have a few slides on AI and IoT. That's a new term called AIoT. That's artificial intelligence of things. Obviously, we'll have a little bit of introduction of AI. How AI and IoT meets together. What are the challenges? What are the spaces that AI and IoT works together? A few of the case studies that we have done with the customers. Obviously, live examples, live case studies that has been implemented up until now from our end. And then obviously we'll have a round of questions if there are any. So if you can see, this is exactly what we do. The Softweb Solution was founded in somewhere around 2004. We are a Chicago-based company. We opened a new R&D and innovation center here in Plano last year, and I basically moved from Chicago last year. The concentrations that you see over here, we do IoT, we do AI, we do analytics, and we do experiences. Experiences is something, regular consulting, mobile app development, web app development, AR, VR, MR, and a whole lot of those kind of experiences that we provide. IoT, we have solutions, we have products, we have services, we have consulting surrounding to the IoT space. Similarly, AI, cognitive that we say, and analytics as well. So we have, the top is all the product lines that we have. We have a product and framework called SIA, that's Softweb Intelligence and Analytical Platform and Framework. That comprises of 3 different platforms for IoT Connect, that's the IoT platform. We have the data ingestion platform, and we have a machine learning platform that together forms a framework called SIA. We have some market-ready SaaS solutions, so 9 in total, and the other 6 are in production right now. Obviously, you can see it's varies from smart factory to building to different implementations that we have done with connected workers, and asset monitoring, and all the other solutions that you see on the screen. In total, as I said, we have around 9 solutions that relates to IoT, and then we have Field Alpha for field services, and Project Allen for chatbots, chatbot development, and everything surrounding to that. We also provide AI as a service. We have 15 some models created internally, all created with using Python and other programming languages. Proprietary algorithms, tried and tested on all of our 9 vertical solution, market ready solutions. And then obviously these are kind of in algorithms and models that can be used in any of the other applications out there. So we provide AI as a service. And then we also do digital and AI solution like mobile application development, web application, and anything surrounding to AI, or that fulfill AI journey or fulfill IoT journey altogether. That's what we provide from a consulting standpoint. We do provide services a lot. I don't want to go much in detail about it, but anything with IT consulting services, that's what we provide as a service. A very partial list of our clientele, so Bosch, T-Mobile, Fujifilm, Pepsi, Qualcomm, Electronics. This is again a partial list. We do a lot of IoT, AI, and experience works with these kind of customers. So talking about IoT and AI, basically what's happening is since past many years, there's lots of data getting collected, and now everybody is realizing that IoT is obviously important, but it's not the only way to go forward with. There's lots of data that's getting collected, a lot of data analytics needs to be done, and that's where we are forming a new term, AIoT. It's a trademark by somebody else, I don't want to say who, but the idea is artificial intelligence of things. It's not just artificial intelligence, it's not just Internet of Things. There has to be a combination between AI and IoT, then that's what the term is, AIoT. The next slide talks about waves of innovation. So obviously, This is how the innovation is pretty much happening. So up until now, like probably 10 years or 12 years ago, everybody was talking cloud. That okay, I have an application, there's a cloud available, let's do cloud, I need to deploy my things on cloud. Most of them didn't knew at that time what's cloud, but everybody is doing cloud, so I need to go to the cloud. That was kind of a thing that was happening. Then obviously came IoT 3, 4, 5 years ago. As I said, IoT is much older than that, but the terminology, Internet of Things, is around 3, 4, 5 years old. Everybody started to go, okay, let's have a device, let's connect a device, put the data to the cloud that's already there, and see how how visualization might happen from a cloud connected devices. Then obviously there came edge. Everybody thought that okay, getting that amount of data or telemetric data on the cloud could be super expensive because you don't need temperature readings of every second of a room to go to the cloud. Then the edge terminology came into the picture. Everybody talked about okay, let's put the data on the edge, let's put analytics on the edge, let's put machine learning on the edge, and take the data that's important to the cloud. Let's not take the entire data set. Let's take the importance, let's take the intelligence onto the cloud, and then again pre-process it and create some more intelligence about that edge data collected. And now we are at a stage where breakthrough of intelligence is coming through. It's called artificial intelligence. Again, artificial intelligence is also not very much new. It was pretty much used in most of the manufacturing industry, most of the healthcare industry, and they are all very old technology. Python and R programming and everything that you know about it. Python almost died but emerged few years back again. So that's kind of in programming. The problem with artificial intelligence and machine learning is you don't get good Python developers anymore because the technology died at some place. So this is, the waves are coming back again. Artificial intelligence is more focused towards creating intelligence on the data that's getting created. Along with IoT, along with historical data sets, how everything can be combined together and an intelligence can be provided. And that's where the wave of innovation is all about artificial intelligence in these days. Quickly covering artificial intelligence. Before that, we need to understand what is a basic intelligence. Obviously, everybody know about it, but let's take within a small example. So say for example, you are going to a store and you want to buy some clothes. Say we are going to a Gap store and I want to buy some clothes from a Gap store. Now as soon as I go to the store, and if suppose I went during say Thanksgiving to a store, and then I realized that okay, during Thanksgiving there was like super good offers that were happening in the store, and when I went there I almost bought a pair of jeans and like 50% off. That's a basic intelligence that I got once I visited the store. Now what would happen is, once I visited the store, I remember that there is a little bit of discounts going on during that time of November. Again, I'm still learning. I don't know what exactly that day is called. I don't know about Thanksgiving. I don't know about end of November. But still, that's a learning pattern that I'm creating. I went to a store. I got super cheap clothes. I liked it and I remembered it. The next year, when the same thing happens, I'll still remember. Okay, it was somewhere around November. Let's try going to Gap store again in November, and boom, when I went there, I got a notification from the store that hey, today it's like 50% off on a pair of jeans. It's a confirmation that something is going on in the end of November, in the Thanksgiving season, and that's where my mind, I'm creating my own intelligence called a regular basic intelligence. Now I always remember that during Thanksgiving, if I go to a Gap store, I'll buy super good and super cheap pair of jeans, and that's where the intelligence is coming from. My mind is able to generate that intelligence automatically, and that's because my mind is made to do that. Now when you talk about artificial intelligence, this is where the machines, or this is where the machines have to go so that they can think about itself, they can see how the data patterns are, they can see what benefits they can create from that particular data sets, what are the technologies they can use on that data set. But the idea is how the machine can be more and more intelligent and provide these kind of results or these kind of an intelligence right from them itself. They don't need people to talk about, okay, spend 2 years of time and then realize that okay, there's something good about it. How they can spend like 20 minutes of time running an algorithm on the set of data and create that kind of intelligence that November 26th or the end of November is always Thanksgiving and you will buy super cheap clothes during that particular time. Few how the industry is going. So obviously we have few leaders talking about cognitive computing market, how they are growing. Obviously in 2025 it say that it will hit the 2 trillion mark. We have other companies talking about like in 2035 AI can double the economic value of the entire company or an organization. So the more we switch to artificial intelligence, the more we utilize artificial intelligence at the best. It's basically providing an economic growth. Obviously, there are a lot of concerns going on that jobs will be lost, and the regular blue-collar jobs will be there. No way, like it will not be there anymore in like next 5-6 years. But the problem is not about obviously the problem is job loss. But the thing is like the new jobs will be getting created using these kind of technologies. People need to learn by themselves, like they have to follow this particular route, they have to be involved in artificial intelligence, and obviously new kind of experiences or jobs will be created. A very basic example, when iPhone was launched in 2007, there were so many companies flourished doing iPhone development, doing Apple development kind of programs. But if you see now, these days, there are technologies available that will do like iOS development in like a month. You don't need to spend like 6 months of time to create something very specific, very unique. And these technologies get enhanced by themselves. So the way the technology progresses, we have to progress with that kind of a technology and understand, learn, utilize that technology, and basically provide more value to the community, to the economical growth of each and every one, from an individual standpoint and also from an organization or a company or a country standpoint. So just to tell you about understanding AI. So AI is basically set of few things. When you say AI, it's basically a combination of speech recognition. So a lot of Alexa devices, Google Home devices, Siri, OK Google, Hey Google, and all the things are going on. So that's kind of a progression where the industry has seen that from a consumer standpoint, it's very easy to penetrate that particular market. Speech recognition is one of the first foremost thing that Siri was launched with understanding speech. Even though that was not good, I don't know if it's good at this time as well. I'm an Android user, but no comments about it. But the thing is, speech recognition is a part of artificial intelligence. Industry picked it up quite early in stage because of consumer needs, and because of they see the market from a consumer standpoint is going towards that area. Decision making is another example or another part of artificial intelligence. So how a decision can be made on the collected set of data. Could be in manufacturing, could be in healthcare, could be in all the verticals that you want to apply it. But decision making is an integral part of artificial intelligence. Virtual perception, natural language processing, problem solving, deep learning are all different ways that we interact with the data, or different ways how we are doing artificial intelligence, creating intelligence on set of that particular data. Again, we will like example. Let's see how artificial intelligence pretty much works. Over here, we have a small kid and his dad, and the dad explains to him that, hey Johnny, don't lean so far forward on the couch, you will fall. Now this is a small kid, I have a 7 months old and I don't understand anything. So how a kid would learn from doing these kind of activities, or how a kid would learn from his dad that he's supposed to do this and he's not supposed to do that. So there is a natural progression what happens from a human standpoint. So the kid has two options. The kid will actually say that, okay, dad gave him an example that, see this glass, if I throw this glass down, the glass breaks. This is a very good example for the kid to understand that something is wrong. If I fall from the couch, I might break myself, I might break my leg, I might break my nose, or something might happen. But now a kid is having an option to either follow that particular process or try by himself. This kid is not unique, so he tried by himself. And he lately realized that yes, if I do this, I'll fall. And when I lean too forward, I fall down. And I broke something, could be a nose or something. So he said that, okay, I'll be careful so that I don't fall down from this particular height again. And this is where artificial intelligence comes in. So now artificial intelligence is pretty much providing two types of learning. One is supervised learning and one is unsupervised learning. Now what dad did while throwing a glass on the floor, he provided supervised learning to that particular kid, saying that, okay, this is a data set, this is what, if you do, the dad said that, okay, if you fall from here, you'll get hurt, but the kid didn't understood. He gave an example that, see, if a glass falls from a table or to that particular height level, glass breaks. So that's in supervised learning where the dad said that, okay, I gave you an example, I gave you a set of instructions, and then I showed you how it happens, and then the glass broke, and that's a supervised learning pattern that artificial intelligence uses. Now, if a kid has been more intelligent, if a kid was like 10 years old rather than 3 years old, he would provide an unsupervised learning that if a dad says that, okay, this is what you will do and you will fall, the kid is smart enough, the kid is intelligent enough to provide unsupervised learning patterns by himself and understand that this is a true statement. And again, from his experiences, from his past behaviors, from his behavior, he will understand that the dad doesn't need to show him an example of a glass fall, and that's where unsupervised learning comes towards it. Again, the more mature the kid becomes, the more mature the unsupervised learning patterns become.
Do you have teenagers?
I just have a 7 months old, and I just have.
Yes, that's actually disproves artificial intelligence.
I'll say one of the advantages that you mentioned about learning is that you don't have to learn once, and that is spread across all machines. So, like an example of a Tesla, when they have an accident, they learn from that, and then the advantage of machine learning is that you only have to teach something, learn something one time, and that is spread across your entire enterprise. Or in the case of Tesla, all the cars automatically get that update to prevent that incident. So that's one of the advantages of machine learning.
But the problem is with the Tesla example you just gave, it's a great global example of artificial intelligence and machine learning. But for the individual who had the accident and potentially lost their lives, that's not acceptable.
True, but if you statistically,
True, but means that you disagree with everything that comes after that.
Statistically, though, but statistically, if you make one,
Statistically, I understand.
Statistically, like, okay, there's going to be 50,000 deaths a year, and if you can save 20%, 30%, but yes, for the individual that unfortunately that caused.
But it's an efficacy issue in the programming, and that's really my point. It's not the point of the Tesla, it's the point of the efficacy that has to be developed in artificial intelligence, machine learning, that you have to actually ethically, you have to look at the efficacy of how you do that and what the acceptable failure rates are on a case-by-case basis.
Well, the thing is that you don't repeat. The biggest thing about machine learning is that you can you make a mistake once, and it can be learned, and so that is now prevented it going across whether it's a car or
I
another
totally
machine.
agree to the point, and I agree to that point as well. So what happened again with Tesla? I have Tesla stocks, but I don't I don't take his place. But so again, artificial intelligence is very new. To provide that intelligence in terms of autonomous driven car is unique. But the problem is, it's not 100% accurate. So I agree, the programming that needs to be done, for such a use case where you're driving a car, you're relying on that particular car, that you will not go into an accident. But again, Tesla backed things up saying that, okay, we are not guaranteed 100% ratio. We always tell that a driver needs to be present behind the wheels, even though it's an autonomous car or it's a semi-autonomous car. It's the responsibility of driver to validate those decisions. Now, when we see artificial intelligence, there is a very good example of a company called ROS. So ROS is a artificial intelligence lawyer that was created on top of Watson, IBM Watson. What they did was
oxymoron?
Sorry.
Is that an oxymoron?
So that particular intelligence for lawyers, it's a program called ROS was getting created. It's already in production now. Now what it does is basically advise lawyers or so Watson fed all the law material into it for hundreds of years of cases. The data gets processed, and now it has an intelligence of creating basic problem solving basic problems. So there's a lawsuit of $100,000 on somebody. So it will compare all the previous cases that happened, where in no way a lawyer as a single entity or even a group of lawyers would be able to check all the 100 years down the line data and pretty much provide an intelligence that, okay, this was happened in 2001 and this is something similar from a case standpoint, this was an outcome of that particular case and how lawyers would pretty much take that thing forward. Still the decision making is from, lawyer or doctors needs to do that, but the thing is, it's a suggestive approach. It suggests them, okay, this is what the technology suggests now, you being a human being are more intelligent right now to decide, do you need to go forward with this kind of a situation, do you need to take my suggestion or process it in the other way that you are more experienced with. So that's where technology is enhancing, but it's not 100% there. It will be still many years to that to come towards. Although we are talking about autonomous car, we need to make sure that the artificial intelligence and everything created, programming is all accurate. But it's still far. Like I don't see that thing happening in next 5-10 years. From a 100% standpoint, the decision-making power is still with humans, and it will remain with humans for quite some long time.
So in your autonomous car example, there's going to be a long road where you're going to have autonomous cars on the road, and then you're going to have non-autonomous cars on the road. So the autonomous cars on the road will have algorithms and communication protocols where they can predictively work with them. It's the non-autonomous cars that are going to be, somewhat problematic. I mean, the NHTSA framework for V2V and the level 5 autonomy comes out in 2023, and that's where the proverbial rubber hits the road. But the issue is going to be all the people who don't give up their old cars.
That's true. Yeah.
So how do you have your AI algorithms and your autonomy computer algorithms work in that regard?
So it's a good example. It's an example of exception handling with AI. There's a lot of stuff going on. So say for example, if suppose we have written an algorithm to detect a number plate on a truck, doing our fleet management and everything, what would happen if the AI is not able to determine that number plate correctly? Obviously, it's not a life-threatening issue, but still it's an issue. So it's an exception handling. What happens in artificial intelligence is obviously it has to be programmed, it has to be written, it has to understand what those exceptions are, and again, as I said, it will take a lot of time to get end-to-end results from an autonomous vehicle standpoint.
But that works in the world right now.
Sorry?
Level 3 works now with.
Level 3 works the road,
Yeah.
level 5 does not.
Oh no, completely agree. But I'm saying that's part of the beauty of machine learning and auto. And AT&T, I know a little bit about this. AT&T supports all 27 major car brands. It's all of our connectivity. So I have a little bit of exposure to this, and that's the benefit of it. Machine learning, you can work in the human world,
right,
with in level 3, and so you're going to be able to identify cars and other vehicles. So it's just another vehicle. Doesn't distinguish between that's another autonomous vehicle or not until they are going to work on vehicle-to-vehicle communication. There's several protocols out there that at least AT&T is currently experimenting with. So that's just going to get better and better. But autonomous driving, even level 3 or 4 or 5, it's just designed to work with another vehicle. It doesn't distinguish between
autonomous vehicle or
yeah, it doesn't. It treats itself.
This is where the use cases are critical, and this is where people still contribute, right? Because, and even to the point, Pete, about at Tesla, it's understanding those exceptions and in fact what's the probability of each exception, and teaching giving the software the opportunity to learn from that. So what does it mean when only a fraction of the cars are self-driving and the rest of them are not? What does the autonomous car have to watch for, as you were saying?
Yeah.
So I think that what is really interesting is we've now had for at least 10 years cars that have the option to keep a safe distance from the car in front of them, and they're smart enough to understand that somebody cuts in front of you and things like that. Just having 25% of the cars on the road equipped with that has dramatically reduced the number of accidents at speed on highways. So it doesn't take much, right? It starts to shift quickly. You don't have to wait for the perfect world when 100% of the cars are self-driving. Just putting a few cars out there who are not tempted to stay on cruise control 2 seconds too long makes a big difference. So I think that this is where, from an AI developer's perspective, it's making sure that there's this huge investment in what if use cases. Because that's where we have the opportunity to make a mistake and kill some people, although it's fewer people than with human drivers. So I guess that's, again, my message is how do we use people? Because they're still a very important.
It's training. So you can explain how this model, you're basically explaining how it works, is how you train. And training is when you develop a machine learning model, that's the most important part. And that's an ongoing development. So you don't stop training.
It's always, AI is always progressive. It's not that you do it once and you leave it, and then obviously, there has to be, as the gentleman mentioned, there has to be training occurred. So training is a process where, you take, so you have 100% data set, you divide that data set into 20 and 80% of it. You probably could be using that 20, 30, 40% of that data set, train the model, see the results, create your accuracy, and depending on that accuracy, you either retrain your model, retrain the model with a new set of data, and then go to the production models where you are having a live data set, trained on the training data and see how it progresses, how it behaves with that particular data set. And again, if there are problems, you go back again. It's a recursive route, but at the end you'll get 95 to 100, not 100, but 95 to 99% accuracy that we deliver. And that's the recursive process. It's a process how the algorithms are written. But again, the use cases are different. It's a different way how Tesla proceeds. It's a different way how we do with smart manufacturing or smart factory use cases. For health, medical use cases, it's totally different. So again, depending on what kind of accuracy we are looking for, obviously everybody needs to achieve 100% accuracy, but that pretty much drives by the use case. So Tesla, for sure, life-threatening issues, they have to be making sure that it's 100% accurate. Even though not today, but it's progressing. The more things happen, again, I don't say the more accidents should happen, but the more the algorithm learns by itself, probably within like next few years, it could be a possibility where they're having a fully autonomous car that could drive.
You have to be very careful. You do not want to overfit your model for a specific training set or test set. The key is to make the model as general as possible, so that when it sees an unknown piece of data, it is able to apply what it has learned to the unknown piece of data. It's very easy to end up with a model that's overfitting a particular set of data, and then it doesn't know what to do when it sees a new piece of data that hasn't been classified, which was exactly the problem that caused the guy to get killed. Because when he was driving hands-free, the vehicle wasn't able to distinguish the edge of the 18-wheeler, and because of the heavy reflection of the bright sunlight on the side of the 18-wheeler. So the vehicle thought there was no obstruction in front, and the car went and hit the 18-wheeler and he died. So you have to be very careful on how you train the model. It's not just the accuracy, but whether the model can be generalized to new data.
Yeah, again, it all depends on the use cases. So like, we have models created for smart factory applications. Again, it becomes like, where are you tying those models? So if we have a model that is very much specific to a factory environment with PLCs and different machine sets that we are using, so that model is pre-trained. That model knows that this is the kind of data that will be getting generated. There is no way that you can generate another set of data from your machinery, because your machine has just 10 parameters and you cannot have an 11th parameter added to your machine. So again, it all depends on the use case. It all depends what kind of data it is, what is the real world example that we are taking towards it, and then again, AI has to grow by itself. The thing is, it's not 100% there yet. It's a progressive thing that will always go around. But it's a good timing, like, we are being into an age where we have seen iPhone, we have seen autonomous, we will be seeing autonomous car pretty much. So the technology progression that pretty much take like 50 years for a technology to progress, now it's been reduced to like 5 years, and you are seeing new technologies coming every less than 5 years from a time standpoint. Again, this is kind of a correlation pattern. So pretty much how you can find patterns between the set of data. So AI is all about finding patterns. It's all about having that data set, processing that data set, and find patterns between that data set. And once you find a pattern, once you're able to find that, okay, this is an 18-wheeler truck now, and I need to understand that's a truck, even though there is an, problem understanding from an AI standpoint, but, you have to find a pattern, with a machine set of data, and once that pattern is identified, the algorithm would be able to determine what it is and how to proceed with that particular exception.
What's that a graph of?
So it's a graph of states and different so concentration of patterns. So we did a smart city implementation with the data set. So 311 calls and all the other calls that you get in the city standpoint. And we did how the 311 calls are between different states, what are the different patterns, what that pattern was generated for that particular data sets, and the higher concentration patterns, where you see correlation between Oregon and I cannot read it, it's too compressed, but so Oregon and roaming, so that's a pattern created on these two particular states. Obviously there are a lot of parameters that we provided to create it. And so it's a correlation pattern graph that was getting generated with the city data that we are executing. So again, next a few slides about how AI and IoT is meeting together. What are different use cases out there where we are seeing those interactions being happening, and again real world examples where it has already been implemented. So to start with retail, obviously there are a couple of challenges with retail. There's a very poor inventory management in retail. So obviously those are like big brick and mortar stores. You have to store a large set of inventory, even though not knowing about what's the outcome of or how many users are going to buy it. So when Thanksgiving comes in, Walmart will go and pretty much create an inventory of tens and hundreds and thousands of items, but unknowingly. Obviously they have now data, so the data processing and everything is happening, but still there's a challenge of poor inventory management in these stores. And then no understanding of the buying pattern. So we are working with retailers where we are installing cameras, we are detecting where the user is going. So if a 30-year-old guy going from a food aisle to a beer aisle versus a 60-year-old guy going from food aisle to a refrigerator or milk or what sort of different section is. So how? So again, I didn't wanted to say very specific terms. I want to be generic. But again, the idea is all about patterns, like how you can determine that particular pattern in an industry. So buying patterns are not clearly identified in retail. Obviously, the betterment is you personalize recommendations. So you have personalized recommendation algorithms that will again, with a set of data, it is able to recommend it, okay, this guy will buy a pair of jeans versus the other lady will buy a shoes or a purse. So again, improved inventory management can be done with these kind of data sets because your buying patterns, the buying behavior of the users, what they come in, what time they come in and what pretty much things they're going to buy. And that's, where brick and mortar stores are trying to get these kind of data. And again process these data and make things available based on the data sets. A very good example who did that was Amazon Go. If you go to a store of Amazon Go, I don't think it's there over here yet, but it's more focused towards autonomous shopping. So they provide an autonomous shopping experience. I don't know how much you have seen Amazon Go, but if you're an Amazon member, you go to a store, there is nobody working over there, you just walk into the store, pick the item, put it in your cart, and from camera, from visual interaction from cameras and all the other activities that you are doing, the algorithm will determine what you are taking, what you are putting into your cart, and there is no checkout process. You just go out of the store and everything would be deducted from your Amazon account itself. So it's a new pattern where a company like Amazon, obviously a more technology company, determining. They have pretty much a very good recommendation algorithm for the website itself, but how they are moving forward with the retail experience is creating these tools called Amazon Go. Go in, pick items, come out, don't even worry about what you're buying. Again, exceptions could happen. I might go in, buy an iPhone, and I could see a bill of the invoice would be for an Android phone. But these are exceptions. Obviously, they have algorithm that will be able to process it and pretty much be more and more accurate as the people uses it.
It's from this crowd, from an IoT perspective, it uses a lot of sensors in addition to cameras. So pressure sensors, there's not only algorithms and on the actual devices itself, there's actually RFID tags. There's a lot of things that you can, technologies that it's not just a very simple, they use a camera.
No, exactly.
Yeah, so
I
like-
apologize, I didn't mean camera, but
Yeah, yeah.
all the sensors, but camera is a major use of it. Obviously, I agree, pressure sensors, we do smart shells, we know how those things work. So again, yes, there are a lot of sensors, but camera is more important. Camera is the important one because it determines who's coming in. A lot of facial recognition happens, a lot of tie-ups happens with their Amazon account, and yes, camera, but yeah, there are other sensors.
But it's also the phone, your device, so you have your phone, so you always have an IoT device. I work a lot with Amazon and Walmart, and so that the key is that you have to have it all. It's not just one component. Cameras, I mean, a very important component, but it's your device, it's the pressure sensors that they have, a variety of different sensors that they have in the smart shell. So when you look at it, it's an ecosystem, in my opinion. Like, it's not just one component, and especially the algorithms get better and better as they train, but that's why they needed a store, because that was their training model, both internally and then externally. But if you think about when you're dealing with machine learning, it's an ecosystem. It's not just I have an algorithm. It's all the hardware, firmware, middleware that goes on with developing that type of solution. All the back-end connectivity, and it's pretty amazing. I encourage if anybody has a chance to go to Seattle to go. It's pretty amazing.
They're funny.
Yeah, that's
Yeah, true.
That being said, ask me how I just got the new 8-inch Kindle Fire for $8. Okay, based on how well their algorithms work.
Well, I'll tell you, they're gonna. But see, the problem is like so. What we've seen.
Just bought it.
What we've seen in a lot
This
of.
week.
Well, we've seen a lot of. So at AT&T, not to plug my shop, but we have all the Fortune 500 come through our foundry. I work at our IoT foundry, which you're about to start working there. And a lot of customers ask, Fortune 500 will ask. Labor is a very expensive thing. So like we work on a lot of kiosks, a lot of different technologies to eliminate a human. I hate to say it, but I sometimes tell my wife I'm the Terminator, coming from the future. But it's because labor. So you think about, they might miss something, but in the end of the day, they're trying to eliminate a labor cost, and so they say, okay, we might miss 10%, and if it's going to be $30,000 a year, it's probably cheaper than hiring a human when you factor in all the labor costs, everything else, right? Machines work 24/7, right? Unless of course, there's maintenance and other things associated, but that's what we've seen is like when we've had a lot of the Amazon, Walmart, all the usual McDonald's, you name it. That's generally what we've seen is just to eliminate the cost of labor, because the cost of labor is going up, not down. And so, benefits and everything else. So that's the big push that we've seen is like, well, can you make it to eliminate the need of a person? And so both in front of the house and the back of the house and the warehouse and everything else. So and then this is where I think there's a lot of opportunity for a lot of companies that we work with to come up with different sensors and different things, because that's a really key component is this retail technology is, I don't think retail is necessarily dead at all. I think it's just, it's going to have to change and evolve, and I think this is one way that's doing it.
So it's really important to talk about what's going to happen to those people. And if we skip over, let's not talk about that. Because when we have hundreds of thousands, perhaps millions of people who no longer have those jobs, that's people who don't have any money to buy anything. So we have to be really careful to understand what, and we can't just blithely say, your new job is in developing use cases for better AI learning. Not likely if you used to work at the pick and go at the Amazon warehouse. So unless we have some very good training programs lined up to get people into those jobs, and I'm sure Pete's got a big plan for that. But the government, no, this is where government's supposed to look after people and make sure that those new training programs are available before we take out a few million jobs, not after, and then all those people and Jeff Bezos all has to lose a couple $1 billion in net worth because nobody can shop at his store. So I think
that's actually less likely. I think they're actually going to kill him like
I mean, this
I don't think so, but all I'm saying, guys, is we all do this, and we've done it for decades, is we skip over the point of this project is to slash staff by X.
But this
We
is a
can't do that
paradigm.
anymore.
But this is a paradigm that's been happening since 40 years.
I know, that's what I just said, Pete. Yep, and we have to stop now, because now we have technology that makes this dramatic. We're not talking about take 10% of people out of here, we're talking about eliminating entire jobs. And And anyway, I'll stop there, but I'm just saying, please, folks, don't skip over the, oh, I won't tell my wife. Like, come on, we gotta face this as a culture.
No, again, where we come from is, so again, the technology is not replacing people yet, I would say. Again, sorry? So again, these kind of technology, it's not there yet where Walmart would be able to implement this technology in next couple of years and fire all the people from there.
But
There has to be-
McDonald's is putting kiosks in to replace the people.
So again, it's a technology. So if you see a business, so business will take their own decision. Obviously, there would be philanthropic, there would be other activities involved into it. But it's a business. They'll take their decision the way it has to be. Honestly, so say for example, you're buying a car. Who's manufacturing a car for you right now? Versus who's manufacturing a car in like 20 years ago. So things changes. It's a technology progresses. Things changes. People train in a newer field. Obviously, we all have to work actively about how those changes would happen, where we need to make sure that a group of people, like 50% reduction in labor, where that labor is getting used. It's a huge topic. I would just give an example. So I was speaking to one of the city event, and the county officer, the police officer came and they asked the question that you are talking about autonomous vehicle in the city. Okay, I agree, like in next 5 years, there will be autonomous vehicle in the city. Whom do I ticket? Or whom do I send a ticket? My county works on those ticketing systems, works on those money that is getting generated from that ticketing system. There are lots and lots of problems. There has to be a solution, and from a community standpoint, from a technology standpoint. Yeah, so there has to be a solution.
The tickets change because the car won't speed, it won't go through red lights, and it won't park in an illegal spot.
That's the
So
problem for that officer.
It's not a problem.
No, for that officer,
It's a
because
problem for that officer because he
Yeah.
doesn't have a job anymore.
exactly.
You know,
Not just job, they don't.
are the things, right?
County will not have money to support other features, so they are generating money from these kind of an activities, but it's a problem. I would say it's a good problem.
Yes, it's an opportunity, absolutely. The opportunity is they need to evolve their revenue stream, because they can't rely on tickets for parking in the wrong spot or speed, right? So all of it's got to move along, not just the technology, not just
Yeah.
the commercial structure.
Somebody will hack the
All of
cars
it
and
has
make us
great
spend it.
point, great point.
So again, the example was there are challenges, there are problems. AI is coming, there are challenges. Sorry?
I just tell them.
They'll hack the cars and make us spend.
Yeah, they will. So there's the case right now where they hacked this John Deere tractor, you got all of this John Deere tractor. Yep. Yeah. So go to the next slide.
So again, human is always a concerning topic, there is no end to that discussion. We have to move forward. So manufacturing, underutilization of resources, more energy consumption. Obviously, there are ways how they can be taken care of. Optimizing labor hours. So again, don't eliminate labor, but how that optimization can happen. So today we are working with manufacturers where obviously their use case is to save money, but save money in the optimization of labor. So we implemented a smart warehouse solution where they have seen that okay, a lot of labor sits at the end of the warehouse and the manager doesn't know why. So we implemented a warehouse solution, shown them that your major products that are going to a conveyor belt is stored at the end of the warehouse, and it takes like 15 minutes round trip for a forklift to pick that products. So again, it's not eliminating that labor, it's about optimizing and telling them, okay, put that things in the front or in the rear of your conveyor belt, because there can be optimization things that could be happening. Again, improving supply chain is the other use case. G is doing that, so avoid unplanned downtime and predict equipment failure is something what G started with. A lot of Predictive platform and a lot of different platforms that is support is doing these kind of activities to save money. Again, automotive, I'll not go much into this because we had already talked about Tesla and everything. But this is more focused towards dealership. So like we work with Microsoft, we work with their partner. They need to understand how the cars are getting stored in the dealership, how many are there, how many they have to order, of which color, and again what is the buying pattern of the user, and do I need a more white car versus a grey car? That's kind of the challenges that we worked with few of the customers along with Microsoft. As an example, GM is doing that. They are improving the dealership performance. So how a dealership is doing, having different attractive benefits for that particular dealership. Again, implementing the solution technology and how they can get benefited from that particular solution. Healthcare, similar challenges. So difficult to predict the number of patients coming into the bed. So we work with a few hospitals here in Dallas, and the emergency unit doesn't know how many beds do they want. There has been catastrophic challenges when there are hurricane seasons, or when there was hurricane in Houston. They were all feared that their beds are not enough to actually sustain or to actually fulfill the requirement due to these kind of hurricanes. So how those challenges can be figured out, how those challenges could be triggered, and again betterment of the people, how they are knowing that okay, there is a hurricane, they need 100,000 beds for an example, and how that beds can be created, how that bed can be supported, and how the patient, inpatient and outpatient flow can be created. That was one of the projects that we did for a few of our customers. And we also have a solution for side effects and clinical trials and everything. So NHS is doing that. Focus on critical diseases. So how many patients are coming for H1N1 viruses and how they can treat that kind of a patient. That's more focused towards how technology is helping the healthcare industry. So again, Rolls-Royce is a good example. So they changed their pattern of buying those aircraft engines on the use of per hour. So that's another way how the technology would pretty much create new business challenges and outcomes and solve those critical outcomes. So now they don't rent their engines on a daily basis, they rent the engine on an hourly basis to their end customers. And again, they own the data, so they can make better engines moving forward and obviously take that challenge out. Automotive, we have different driving-based behavior. As I said, I'll not touch this portion. There's a lot to talk about. So
AI right there.
I am an intelligent guy, so I don't want to do that. But again, guys, there's a lot of interactions happen, good interaction with all of you. As I said, AI is a topic where everybody is interested to talk about it. Everybody is interested to see how it can help. There are very much challenges with the people, with the labor, and again, being in a technological world, being in this kind of environment, we have to work together to figure out those challenges, problems, and solutions towards it, and not just say, okay, I'll not implement something because I have to fire 500 people. The business will implement it, no matter how harsh the decision is. But obviously, from a community standpoint, we have to identify what that, how that can be utilized, or how the labor can be utilized in a different way, different fashion, in a better way. So next 4 or 5 slides, I know I might be on over time now, but 4 or 5 slides are just focusing towards what we have done with these kind of an industry. Cummins Allison is one of our customer. They manufacture ATM machines. We did IoT and AI with that ATM machine. Did a smart field service implementation with them and focused or showed them how your field service. So their current downtime for a ATM that Bank of America might be using was like 7 to 10 days because the field service guy goes there and see, okay, this is a problem, I don't have part, go there back again, order the part, come back again, fix that part, and the entire cycle took like 7 to 10 days. We reduced that particular thing to like 1 to 3 days with part detection with pretty much, so we had like I think so 5 years of field service data from Cummins Allison, all the activities that happened, we processed it, gave the algorithm, ran the algorithm, and now we are able to predict that let's send Joe to fix this particular problem because he's very much good in fixing screens rather than fixing trays. So these are kind of a solution that we provided to Cummins Allison. The next is asset and equipment monitoring. So we work with customers where so we are monitoring their raw material, we are monitoring their assets for raw material, how obviously using RFID cameras and different sensory equipments over there. But the idea is how you can monitor your raw material so that your production doesn't change, the production doesn't get affected. So we work with few manufacturing customers, implemented things in the warehouse, implemented things on the racks, RFID solutions on the racks to determine those kind of patterns and again take that data out and predict on that particular data saying that okay, you have to pre-order this particular inventory because this is a Thanksgiving season and you will have to manufacture these more. So this is kind of an algorithms or the solutions that you're providing to the customer. Retail, so Mandalay Bay, we have implemented a smart retail solution in the shopping area. So again, beacons, cameras, sensors, temperature, humidity, and all the sensors that we will be able to use there. But the idea is, so as soon as you walk to an retail mall, there's a big screen that says you are here, and then obviously you have to figure it out. Okay, where is the Gap store? How do I go there? Everything is mobile. As soon as you go to the Mandalay Bay Mall, you'll get notification on the phone. You are here with the map. Select Gap store and it will do the indoor navigation for you and everything. The idea is buying to understand the buying patterns, buying behavior, the customer's behavior, and provide that analytics to the store owners. Obviously, they pay for the solution to know that okay, a Gap store will be able to send notification out to me because I am a Gap customer. Rather than going to a different store, they would send me that okay, hey, you are here in the mall, take a 20% off, come here, buy a pair of jeans and go back. So a lot of user behavior, emotion analytics that we do for these customers. Healthcare, we have solutions for clinical trials. So a new medicine takes like 1 year to 3 years down the line to do those clinical trials, to provide solutions for clinical trials and management of that particular data. So how a trial would be executed depends on that particular trial. But the solution that we provide will make sure that their patient or whoever is enrolled in the trial remains with the trial. So the problem with trials is people go out of trial pretty quick, so they don't take medicines. They have to come to the hospitals on a weekly basis to do their blood pressure and all the other vitals. That thing can be taken care of their home, and we provide those kind of solution to customers. Energy management, buildings, smart buildings. We have like done 4 smart buildings in Chicago, San Diego, and other places. So entirely from ground zero to like 40-floor buildings, we have made them smarter. From hardware, software, implementation, integration. So we've integrated 17 different systems in the building. A lot of IoT and a lot of AI that happens in that particular building, and we are now able to predict what is the energy consumption. The use case is okay, I want to save 30% on my energy. We go back and say, okay, you can do it in like in next 3 years because this is how your patterns are, this is how you use it, this is the solution, this is the cost of the solution, and your ROI will be there. Like just for energy consumption or energy saving standpoint would be like next 2 years. But there are like 17, 18 different use cases that we have covered in Smart Build. Again, logistics, we have worked with a company called MK. They have a fleet of like 90,000 trucks. We have done entire fleet management for these kinds of companies. Again, do a 3-point triangulation, like where is, so if they want to pick up things, if they want to drop off things, what's the best route? If something is not available, real-time route changes and everything for the driver, and that's what the solution we have created. So it's almost to the end. So the idea about AIoT, it's like a train. The idea is we all ride the train, not jump in front of it, pretty much, And this is a technology. So nobody as a single person. So you said it right. It's an ecosystem. It's an ecosystem in a train. You all have to be present. We all have to be, equally responsible for doing activities. One guy or a part of or a group of people will not be able to own the ecosystem and will not be able to drive the ecosystem altogether. Next is thanking you a lot here. We have a couple of offices here in Dallas, back in Chicago. These are our websites, softwebsolutions.com and softwebiot.com. We are here, free to speak, and let us know if there are any other questions for the.
Let's give him a hand.
Thank you so much.